stop running into interruptions. Homework questions so far. Okay. All right, sum and difference formulas. We're getting back to these. And luckily the reference sheet does have all these formulas there. I realize they're a little bit out of order because when I printed them, I was looking at one sheet and had it completely out of order. So all of these are labeled. I do have the sum formulas, I believe, listed together on the first sheet. The difference formulas are supposed to be on the back of the front sheet, but they're on the front of the second sheet. So they are a little mixed up in that sense, but they are kind of grouped together. Because what we're looking at is the sum and difference formulas. So here we're looking at the difference between of pi over 4 and pi over 3. So we have cosine of pi over 4 minus pi over 3. So if we look at the difference formula for this here, cosine of alpha minus beta is equal to cosine of alpha cosine of beta plus the sine of alpha sine of beta. This is just a straight formula. And if we compare it to what we have, well, we have cosine of pi over 4 minus pi over 3. So for us, alpha is pi over 4, beta is pi over 3, and we just fill it in accordingly. So it says cosine of alpha, so we'd cosine of pi over 4, cosine of beta, cosine of pi over 3, plus. Instead of sine of alpha, we'd have sine of pi over 4. Sine of beta would be sine of pi over 3. And this will give us the same value as if we took cosine of pi over 4 minus pi over 3. Now at this point here, we can plug this into the calculator, or we can use the unit circle, because we have cosine of pi over 4, which is square root 2 over 2. And it's being multiplied by cosine of pi over 3, which is 1/2 sine of pi over 4 is square root 2 over 2, and sine of pi over 3 is square root 3 over 2. Now at this point here, we would multiply together. So we do square root of 2 over 2 times 1/2, which is actually square root 2 over 4, plus square root of 2 over 2 times square root of 3 over 2, or square root of 2 times square root of 3 is the square root of 6 over 4, which actually gives us the square root of 2 plus the square root of 6 all over 4 as our final answer. And that's it. So we really just used the formula, plugged in alpha and beta in their respective places, simplified, and we're done. Questions on this here? All right. Well, it does seem odd. I do have 2 of them up there. And the reason I have both of these up here is we've seen square root of 2 plus the square root of 6 over 4, if I remember that correctly. Yes? Or did I get that? Okay, good. If we took these individually, cosine of pi over 4 minus cosine of pi over 3, we get a different answer. We can't just split it up and take the subtraction of them, because cosine of pi over 4 is square root 2 over 2. And if we subtract from that cosine of pi over 3, which is 1/2, we just get the square root of 2 minus 1 over 2. And really what I'm getting at is that these two are not the same thing. We can't just split it up and say that cosine of pi over 4 minus pi over 3 is the same as cosine of pi over 4 minus cosine of pi over 3. And it seems odd to do this, but I mean, in a lot of different areas of mathematics, we can just break it up and do these kinds of things, but there are some exceptions where it just doesn't work, and this is one of them. Now, we can also do this with degrees, because the first one, obviously, we did in radians. The second one, we can do this in degrees. So if we look at the sum formula for sine, so sine of alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine of beta. And for us here, we have sine of 135 plus 35 is equal to. So in our case, alpha is 135 degrees, and beta is 35. Now 135 degrees is on the unit circle, and it tells us that sine is square root 2 over 2. I need to fix this, because I think I said this probably last year. I'm going to look. That needs to be 45, not 35. Because otherwise this problem doesn't make any sense. Because 5... Oh, yeah. It does work, but 35 is not a nice angle on the unit circle. Because if we take the calculator, I need to change it back to degrees. Cosine of 35 degrees is this here. Now, interestingly enough, sine, as we said, 135, yes? Plus 35 is this here, because 135 plus 35 is 170. So it doesn't work. This needs to be a 4. I have to fix that. And as I said a minute ago, I probably need to fix that. I said that last year. So all that's going to do is change these three spots here. 204, 204, 204. Yes, okay, good. Just making sure. 45. And the reason that it doesn't seem like a big change, but it is a big change, because cosine of 45 is on the unit circle. It actually is square root 2 over 2. Cosine of 135 is negative square root 2 over 2. And sine of 45 is square root 2 over 2. Well, square root of 2 over 2 times square root of 2 over 2 would actually be 2/4. Because square root of 2 times square root of 2 is just 2. 2 times 2 is 4. Now that is technically 1/2. We can reduce it, but I'm not going to. We could do it in a minute if we need to. Because we're going to add to it negative square root of 2 over 2 times square root of 2 over 2. Well, that would be negative 2 over 4, which is technically negative 1/2. But 1/2 plus negative 1/2 is 0. Because 135 plus 45 is 180. We could have done this the other way. Does that make sense? Now, the other option I'm going to back all the way up. Because there's one or two things that I could have done on this here. And the other option is that instead of this being 35, you don't have to write this down, is that this was supposed to be 30 degrees. And this would make a little more sense than it being 45. Because at 30 degrees, 135 plus 30 is 165. 165 is not on the unit circle. And that's the real key, if you remember from last year, why we use sum and difference formulas, is because we're trying to find these angles that aren't on the unit circle. But 135 and 30 are. They're both angles on the unit circle. So we can use those angles on the unit circle to find the one that isn't. And I have a feeling this is actually the one I wanted. But both work just fine. Because sine of 135 is still square root 2 over 2. Cosine of 30 is square root 3 over 2. Cosine of 135 is still negative square root 2 over 2. And sine of 30 is 1/2. And what that gives us is square root 6 over 4 minus square root 2 over 4, which gives us the square root of 6 minus the square root of 2 all over 4. Now what's interesting, it'll do it for us. Questions on this here? Find the exact value of sine of pi over 12. Now, I have a feeling, if we wanted to, radians, so I can quit. Sine of pi over 12 is 36 minus square root of 2 over 4. Now, let's actually use the sum or difference formula. Now, if we think of the unit circle, there are 1, 2, 3, 4 different denominators. One of them's 2, one of them's 3, one of them's 4, and one of them's 6. Yes? And we're wanting to get to 12. Well, all of those are numbers that add up to be 12, yes? So I would try to keep it simple since we're looking at 1/12, really. Because I could do, say, 1/6, say minus 1/2. That didn't really get us there. Because we could try it the other way, 1/2 minus 1/6. That's still just 1/3. Now, it might be odd that we're subtracting, because if we're adding, we'd have a bigger numerator, because we're adding two things together. Let's say 1/3 minus 1/4. Actually is 1/12. So for us, that means pi over 3 minus pi over 4 is pi over 12. Now, another way we could have gotten that is, because trying to work in radians isn't always the easiest to think of. I can convert it to degrees, 15 degrees. So now we're looking at 0, 30, 45, 60, 190, 120, 135, going all the way around. And we're trying to get to 15 degrees. Well, that also means we could have done pi over 4 minus 60 minus 45. Or in other words, well, 60 is pi over 3 minus pi over 4. We have that. So that's not what I was thinking. Sorry. 45 minus 30 is still 15. So pi over 4 minus pi over 6 is also pi over 12. There's different ways we can get to it. So we could say pi over 4 minus pi over 6. Is equal to sine of alpha cosine of beta minus, well, let's keep it the same as the formula. Cosine of alpha sine of beta, if I got the formula right. Sine of alpha cosine of beta minus cosine of alpha sine of beta. Yes. Now, sine of pi over 4 is square root 2 over 2. Cosine of pi over 6, square root 3 over 2. Minus cosine of pi over 4 is square root 2 over 2. Cosine of, or sine of pi over 6 is 1/2. That would be square root of 6 over 4 minus square root 2 over 4. Giving us this here. Well, what the calculator told us to begin with, isn't it? Questions on this here? Now this is neither here nor there. But I also said pi over 3 minus pi over 4, yes? Pi over 3, pi over 4, pi over 3, pi over 4. Well, sine of pi over 3 is square root 3 over 2. Cosine of pi over 4 is square root 2 over 2. Minus cosine of pi over 3 is 1/2. Square root 2 over 2. Here we would get square root of 6 over 4 minus square root 2 over 4, which, to no surprise, is the same thing. Questions on this here? So there's more than one way to get at it, yes? And I mean, we could keep doing examples of these. So these are both in the third quadrant, yes? 3 pi over 4, 2 pi over 3. Or over here in the, not third, second quadrant. We get pi over 12. Even though they are different values, quote unquote different values for sine and cosine, it's still going to come back to this here. Because again, all we need is a way to add or subtract two angles to get pi over 12. Because once we have that, we can plug it in to the formula and get what we need. Seven pi over 12. So most likely we're going to be adding. Pi over 2 plus pi over 6. That didn't work. Pi over 2, well, we can't use 2 and 4 because that's just going to be 4. Use 3 and 4. which also means, yeah, those are going to be the easiest ones of the two. We can do others, but they can get a little tricky. Now, cosine of pi over 3 plus pi over 4 is cosine of alpha, so cosine of pi over 3, times cosine of beta, pi over 4, minus sine of alpha, sine of pi over 3, times sine of beta, sine of pi over 4. Now, cosine of pi over 3 is 1/2. Cosine of pi over 4 is square root 2 over 2. Sine of pi over 3 is square root 3 over 2. And sine of pi over 4 is square root 2 over 2. And that's actually it. Questions on this here? Sine is 75 degrees. I mean, there's different ways we can get to 75. It's just figuring out what's going to be the nicest way. Because, I mean, if we want to, I mean, I know which way is going to be the easiest. I could say sine of 210 minus 135. Because 210 minus 135 is indeed 75. Or I can do 34 plus 45. Still get 75. And either way, we'll get to the same answer. Now, according to the formula, this is sine of alpha cosine beta minus cosine of alpha sine of beta. Now, sine of 210 degrees is negative 1/2. Cosine of 135 degrees is negative square root 2 over 2. Minus cosine of 210 is negative square root 3 over 2. And sine of 135 degrees is square root 2 over 2. Now our first one, negative 1/2 times negative square root 2 over 2 is positive square root 2 over 4. Well, our negative and the fact that we have a negative times a positive is going to become plus. And we'd get square root 6 over 4, telling us this is square root of 2 plus the square root of 6 all over 4. And that's it. Now, as I also showed, I could have just used 45 plus 35. So, if I'd have done it that way, one of the biggest changes is, well, we won't have those two angles, we'll have 45 and 35. And because we're talking about a sum, not a difference, we actually add the two. Because this, and that's the interesting thing with the sine, the sum identity for sines, is the signs actually match. Cosines, they are flipped. We get this here. Now, sine of 45 degrees is actually our positive square root 2 over 2. Cosine of 35 is negative 1/2. Really, sine and cosine spots flipped, and they both became positive. Cosine of 45 degrees is, well, square root 2 over 2. Sine of 35 degrees, or 30. Why do I keep doing 35? It's supposed to be 30, because 45 plus 30 is 75. I think that's what I did on the previous one, is I switched it with 35. But 30 is going to be our, here, make sure I got this right. Yep, cosine of 45 is square root 2 over 2. Cosine of 30, this is where it flips. This would be square root of 3. This would be 1/2. Now, it seems like that's going to cause a big issue, but it's really not. Because what that will give us is square root of 6 over 2 plus, okay, that's trying to rush. Square root of 6 over 4 plus square root 2 over 4. Well, I can add two things in any order. We get back to the same answer. So it doesn't matter which ones we use, we just got to make sure that these add up to be 75 degrees. Does that make sense? Questions on any of this here? Now, at any one of them, we could try to see what to add together, subtract from each other, just to make 40 or 75, and that's all we're trying to do. So we can say cosine of 75. So I can pick any angle I want to start with. So we could say, I'm going to pick 225 this time. Subtract 75 from it to see what's going to make a difference of 75. Well, 0, 1, 3, 4, 5, 150. And after I do that, I'm going to see if it's on the unit circle. 150 is on the unit circle, so we can use it. If I pick, say, 240 minus 75, this is just a guess. 3 and 10, so 5. 13. So here, I should get 165. We don't have to do this by hand. 165. Not on the unit circle. So we can't use 240 and 165 because one of them's not there. But 225 minus 150 is indeed 75 degrees. So we can use both of those because the difference is 75, which was what we wanted, and both of those are on the unit circle. Does that make sense how that works? Now this would equal cosine of alpha cosine beta plus sine of alpha sine of beta. Cosine of 225 degrees is negative square root 2 over 2. Cosine of 150 is negative square root 3 over 2. Plus sine of 225 degrees is negative square root 2 over 2. And sine of 150 is 1/2. Negative square root 2 over 2 times negative square root 3 over 2 is square root 6 over 4. Here we have a negative times a positive, which is going to change this to a negative. Or we can just say plus negative square root 2 over 4, which is telling us we have square root of 6 minus the square root of 2 all over 4. Questions on this here? So hopefully we see there are lots of different options that we could have done to get this, because we could have stuck with the two different examples we used on the last one, because I could have stuck with 30 and 45 degrees and added those together for cosine, got to the same spot, but any of them will work. Now, these, I need to fix this, and there's several slides I need to fix just to add the directions. We just want to simplify into just a single sine, cosine, or tangent. Now, looking at this here, is this sines, cosines, sine or cosines, sum or difference formula? It is difference, and it would be sine. And this matches up to our sine of alpha minus beta. And for us, alpha is 3, beta is 1.2, yes? Now 3 minus 1.2 is 1.8. That's all it wants. And we'll pick these up tomorrow.